All right, here we go. Welcome to week 7 of quarter 4. We are going to talk about probability again. This time we are going to talk about something called independent events. And we're going to talk about multiple independent events. So one thing that we have to talk about is what's called the multiplication rule of probability. So the way we're going to do that is we're going to start to look at the flipping of a coin. Okay, it says, suppose you flip a coin once. What is the probability of getting heads? Well, we just have to think about how many heads there are on a coin and how many sides there are on a coin. So it's kind of obvious there's 2 sides on a coin and there's only one head. So if you're unfamiliar with a coin, we refer to one side of a coin as heads because generally there's a picture of a person on that side of the coin, and then the other side is called tails because it's the back end of the coin, so we call it tails, kind of like a dog has a tail. So there's 2 sides to a coin. There's only one head, so the way we identify the probability of getting heads is we say it's 1 out of 2 because there is one head and 2 sides. Okay, so we always make fractions like this, where that's kind of a weird looking word, head, so we've got to fix that. This is the way we look at probability when we're dealing with independent events, is we look at the number of times something could happen. In this case, heads is there's only one, versus the total number of things there are. And in this case, it's sides. There's 2 of them. Okay. Now, suppose you flip a coin twice. What is the probability of getting both heads? And this is where the multiplication rule comes in, because we know that if we flip a coin once, the probability of getting heads is 1/2. But then we're going to flip that exact same coin again, and since nothing changes about that coin, the probability of getting heads stays exactly the same, so it's another 1/2. But since we're doing something twice, we have to multiply those probabilities together, and we multiply them 2 times, just exactly like what we have here, 1/2 times 1/2. So we multiply across when we do that, so we end up with 1 times 1 over 2 times 2, or 1/4. Okay, so the probability of flipping a coin twice and getting heads both times is 1/4. Okay, and then we can continue. It says suppose you flip a coin 3 times. Well, same thing's going to happen. The probability is 1/2 for the first flip, it's 1/2 for the second flip, and it's still 1/2 for the third flip because that coin doesn't change at all. So the probability of getting heads is going to be 1 times 1 times 1, or just 1, over 2 times 2 times 2. Well, 2 times 2 times 2 is 2 times 2 is 4, right? Multiplied by 2 again, it's going to be 8. So the probability of flipping a coin 3 times and getting all heads is 1/8, or 1 out of 8. Okay? How about 4 times? We could keep going, right? It doesn't change, so it's 1/2 times 1/2 times 1/2 times 1/2. So we have 4 fractions now because we have 4 coin flips we're talking about. And so we multiply them all together and we end up with 1/16. Okay, now it says how many times would you have to flip the coin until the probability of getting all heads is less than 1%? Well, the thing we have to think about is these fractions that we just came up with. The first one, 1/4, that's not a 1/4, that's a 1/2. 1/4 is 1 out of 4, or we did some conversion last week, so it's 25%. Okay, 1/8 is 12.5%, or 12.5%, right? And then 1/16 is 6.25%. I don't know if you noticed, but every time we add another flip, so the first 1/4 was 2 flips, the 1/8 was 3 flips, so this was 2 flips, this was 3, this was 4. Every time we add a flip, it's cutting the probability in half, because it went from 1/4 to 1/8, or 25% to 12.5%, and then from 12.5% to 6.25%. So that's half again, right? So if we were to do another flip, it would be around 3%. So that would be a fifth one. A sixth one would be around 1.5. So I'm going to guess it's around 7. Okay, so I think it's going to be 7. And so the way we can figure this out is we can just say, all right, if I flip it 7 times, it's 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2. I think I need one more. 1, 2, 3, 4, 5, 6, 7. All right, and then we have to multiply that. So 2 times 2 is 4. So that's these two. Times 2 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. Times 2 is 128. All right, so we have 1 over 128. All right, and I know right away that this is less than 1% because it's 1 out of 128. And 1% would be 1 out of 100. But I can always double check this. I can just go to a calculator and I can divide 1 divided by 128. So that's 0.008, and if you remember with converting fractions to decimals and then percents, we're going to move that decimal place 2 places to the right, so it becomes 0.8%. So we have 0.8%, which is less than 1%. So I know that I can flip it 7 times and be able to get less than 1%. All right, so that's a little bit tricky to think about, but it's something we should be able to do as we think about probability and independent events. All right, it says here you use the multiplication rule of probability when you are trying to find the chances of multiple things happening. In the coin flipping example, you wanted heads and then get another heads and then get another heads and then another heads. And every time you want this thing to happen, you just multiply. Okay, so that's the multiplication rule. You just multiply those probabilities together. So first we're going to talk about multiple independent events, and next week we're going to talk about multiple dependent events. Okay, so there's a subtle difference in the words there. There's another thing that we need to know, though, and it's called the complement rule to answer some of these questions. Okay, so multiple independent events, what we could fill in here is multiple independent events is so something like flipping a coin, where the probability of an event doesn't change, right? When we flip the coin, nothing happened to the coin to make it any different. So the probability doesn't change. But what we have to do with multiple independent events is we need to multiply the probability based on the number of times that we expect we're going to do something, right? So we multiply the probability the number of times we do something. Okay, so if we're flipping a coin, it's going to be the number of times we flip the coin. Okay, so there's all kinds of different things that are independent events where the probability doesn't change, and every time we're just going to multiply the probability together the number of times we do something. Okay, so the complement rule is pretty simple, but it's something that people have a hard time thinking about. So the complement rule is the probability of something not happening. Okay, so we've been talking about flipping a coin, and I'm not going to use flipping a coin as an example because it's not a good example for the complement rule. But let's say that I'm going to give you two examples. Let's say that you're going to do something, and there is a 3 out of 5 chance, or the probability is 3 out of 5 that, let's see here, the probability is 3 out of 5 that you will skip class. Okay, so that means that you're going to skip class 3 times out of every 5 classes. All right, that's the probability of skipping class. But now, what's the probability of not skipping class? Okay, and the probability of not skipping class is the fraction that we have to add to this fraction to make it equal to 1. Okay, and so the way to think about that is I just have to add something to the numerator that makes it equal to the denominator. So that's going to be a 2, right? Because 3 plus 2 is 5. So the probability of not skipping class is 2 out of 5. Okay, and the reason is because 3 out of 5 plus 2 out of 5 is 5 out of 5, or 1. Okay, so the probability, the complement, is 2 out of 5. Okay, so fractions are a little bit trickier. Decimals, or percents, if we think about percents, let's say that same probability of skipping class is 3 out of 5. Well, if we do the math on 3 out of 5, that ends up being 60%. Okay, and the probability of you skipping class is going to be 60%, and that means the probability of you not skipping class is going to be the number that takes this to 100%, or in this case it's 40%. Okay, so the complement are the two numbers down here that cause the probability to be equal to 1. Well, in this case over here, it's not, it's 100, right? Because 60 plus 40 is 100%. Well, if you remember, 100% is the same as saying 1. So we're getting to that same 1. So the idea of the complement is what's the probability of something not happening. Okay, and so we'll look at a couple of examples, and I think this will help explain what I'm talking about. Okay, so in this example it says Jessica's math teacher decided that for every time she turned in an assignment on time, she would get to spin the prize wheel. Jessica turned in 3 assignments on time, so she gets to spin the wheel 3 times. She really wants a food prize, which has a 40% chance of getting. What's the probability that she gets all 3 food prizes? Okay, so she's going to spin the wheel 3 times. So 3 spins, 1, 2, and 3, right? And the probability of spinning a food prize the first time is 40%. And the probability of spinning a food prize the second time is still 40% because it doesn't change. The probability stays the same. And then the probability of spinning a food prize the third time is still 40% again. So we have 3 probabilities that are exactly the same. And now what we want to figure out is what's the probability that she gets all 3 food prizes? So we multiply these 3 together. And well, we can't multiply percents like this. We have to change them to decimals. So we're going to multiply 0.4 times 0.4 times 0.4. And I'm guessing most people can't do that in their head, so what we should do is go grab a calculator and go to 0.4 times itself. So 0.4 times 0.4 times 0.4. What do we get? 0.064. And so we have 0.064 I say 0.064. I don't say that 0. That's to the left of the decimal, right? 0.064. And if you remember to turn this into a percent, we're going to take this decimal and move it over 2 places. So we end up with 6.4%. Okay, so pretty small probability that she's going to get 3 food prizes in a row. Okay, so now that's the probability of getting 3 food prizes, right? Same scenario now, but let's turn this around. If we look at the next one, it says Jessica's math teacher decided that for every time she turned in an assignment on time, she would get to spin the prize wheel again. And she turned in 3 assignments on time, so she gets to spin the wheel 3 times. She really wants a food prize, which is 40% chance. What is the probability that she gets no food prizes at all? Okay, so this is where we have to think about the complement, all right? And so the complement is the probability of not getting a food prize. And so if the probability of getting a food prize is 40%, the complement, or the probability of not getting a food prize, is that percent that we have to add to it to equal 100%. Okay, so we're going to use 60% now instead of 40% because there's a 60% chance of not getting a food prize. And we'll just do the same thing. So we'll do 60% times itself 3 times. And remember, we can't multiply percents like this. You can on some calculators, but sometimes it's easier just to do decimals. So we're doing 0.6 times itself 3 times. And I don't know what that is off the top of my head, so I'm going to go back over to my calculator. 0.6 times 0.6 times 0.6. And we end up with 0.216. Wait a minute, that's a comma. Let me see if I can fix that and if it changed it or not. .216. All right. So here we go. Where would we go? There we go. Okay, so we have 0.216, and remember we move that decimal 2 places this direction, so we end up with 21.6%. All right, so the probability that she gets no food prizes at all is 21.6%. Okay, so we use the complement, or the probability that she's not going to get any food prizes. All right, try this one on your own, about Jeremy growing onions in his rooftop garden, and see if you can figure out the answer to these 2 questions. And when you're done, remember this is in the red box, so these are you're going to have to submit on Schoology, into the assignment on Schoology. All right, let's keep going and do a couple more examples here. In this next example, it says Jamaria is finishing her ACT test and still has 3 questions to go. So she has 3 questions to answer. So she randomly fills in answer choices for the last 3 questions. There are 5 possible answer choices for each question. What is the probability that Jamaria gets all 3 questions correct? All right, so what we have to think about first is if we have a question and there's 5 choices, the probability of getting this question right, if you guess, there's only 1 right answer, so the probability is 1 out of 5. Okay, so for each one of the questions, since there's 5 choices, the probability of getting it right is 1 out of 5. Okay, and so since there's 3 questions, we are going to multiply that 1/5 times itself 3 times, because there's 3 questions that she has to guess on. And so when we multiply this one across, we get 1 over 125, because 5 times 5 is 25, and then we multiply another 5, that's 125. And so I don't know what that is off the top of my head, so I'm going to go over to my calculator, see if this, nope, it didn't recognize it right. 1 over 125, there we go. All right, 0.008. All right, so we need to take that back over to our assignment. So it's 0.008. And just like every time we want to get a percent, we move that decimal 2 places to the right. So we end up with 0.8%. All right, so a very low probability that she is going to get all 3 questions correct. All right, now, same question or same scenario, but this time, what is the probability that Jamaria gets all 3 questions incorrect or wrong? Okay, so incorrect means the complement, right? So if the probability of getting it right is 1 out of 5, the probability of getting it wrong would be the number that we have to add to 1 to make it equal to 5. So it's going to be 4 out of 5. So this would be 4 out of 5 here. So this is correct, or getting the answer right, and this is incorrect or wrong, right? Okay, so incorrect is the one we want to use here because that's the complement. And so we're going to multiply the complement times itself 3 times. So we're going to do 4/5 times 4/5 times 4/5. Okay, and so this is one where I definitely need to go grab that calculator because it's going to be easier. So I'm going to do 4/5 times 4/5. Ooh, we'll see if it recognizes those. I may have to do this again. Yep, I got to do it again. It doesn't like the little dots. Got to do the X's for times. And we end up with 0.512. Okay, so we end up with 0.512. And again, every time we want to make this into a percentage, we just move that decimal 2 places. So we end up with 51.2%. All right, so there's a 51.2% chance she's going to get all 3 questions incorrect or wrong. Okay, one more that you have to do on your own. Remember, these red boxes, I think this is the first time maybe we've done it this quarter, but these red boxes, we have to enter the answers that we get for these into an assignment on Schoology. So you need to go find that and enter them there.